The Sky This Month, with your host, Dave McDonald.
Welcome to The Sky This Month. I'm your host, Dave McDonald, and this is August 2020. What a great month this is going to be. We have the Perseid meteor shower, the mornings like after midnight of August 11, 12, and 13. You don't want to miss it. Jupiter and Saturn blazing in the southeastern sky and getting higher every night. Then we have the splashdown of the Dragon capsule with Bob and Doug, and I want to see, I hope that you got an opportunity to see that happen. That was really pretty neat when that happened. So here they come, Bob and Doug. This is the first time in 48 years that we've had an American capsule carrying Americans splash down in the ocean, in this case, the Gulf of Mexico, off the coast of Pensacola, Florida. There you can see the speedboat speeding to get Bob and Doug out of the capsule. They got the capsule on board the rescue ship, and then about an hour later, they emerged from the capsule itself. So really pretty neat stuff. And then July 30th, we had the launch of the Perseverance spacecraft. We're going to show you a clip of the spacecraft itself and it being moved from California to Cape Canaveral, and then the launch of it. And Adam's going to talk a little bit about the details of the mission. So stay tuned. We have a great show in store for you. So enjoy these video clips of the Perseverance mission, and then Adam and Seth are going to talk to you about some of the other neat things happening in the night sky. At the end of the show, we talk about the Perseid meteor shower.
The Perseverance rover headed to Mars, ready to ride a column of fire and smoke on its way to the Red Planet.
And liftoff. as the countdown to Mars continues. The perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And Atlas TU has gone to closed loop control, standing by for SRB burnout shortly. And we have successful separation of Mars 2020 with the Perseverance rover.
We now have an acquisition of signals, and the years of blood, sweat, and tears from every person who worked on this mission is now realized as Perseverance makes its way to Mars.
Well, once again, I'm here with my graduated astronomy students, Adam and Seth, and we are going to have a great conversation about some of the neat things that are happening this month, and in a way, some things that are happening in the future. We've got great constellations happening in August, as there are every month, but one of the neat things that has just recently happened, and maybe you saw it on the news at least, is we have a rover bound for Mars that recently launched called Perseverance. And Adam is going to tell us about that rover, and then tell us a little bit about the planet Jupiter, which is also visible during the month of August. So Adam, take it away.
All right, so this is the Perseverance rover that was just recently launched a couple of days ago. You might have seen it on the news or heard about it. And from first glance, you might not be able to notice the differences necessarily from Curiosity to this rover. Up in the top right of this photo here, you can see Curiosity and the Perseverance rover, and they're very similar in the way that they're built. And Perseverance, in the words of many people who worked on it from NASA, it's more of just like an upgraded version of Curiosity, but it has a different focus. And that's the main thing, is what's different, is it's going to be looking for traces of life in the past in Mars, and looking at the possibilities and the obstacles that we may encounter bringing humans as astronauts to the planet.
And I would say, to interrupt Adam, that, like as you mentioned, it looks a lot like a Curiosity, because as we know, Curiosity is still working. I think it landed in August 2012. So we've got 8 years and still going. And so
right.
Technology was very successful. So, why not keep the basics the same and then change some instruments out?
Absolutely. I think one of the main things they mentioned they changed was the wheels were all upgraded for a much more foolproof design. The Martian soil is very corrosive sort of with the equipment, especially the wheels that are always in it all the time. So that was one thing they worked on. Down in the bottom right, that's the landing zone. It's called the Jezero Crater, and it was once a lake similar to the size of Lake Tahoe, so it wasn't small. And if you can see at about 9 o'clock on the left there, and at about 2 o'clock on the right, you can see sort of what looks like riverbeds leading into it. And if there's any place that you could find remnants of life, I think that would be the spot, in my opinion, because bottom of a lake, something like that, there's going to be a lot of microbes and possibly, if anything bigger, fossilized life. The people that I was seeing when they were being interviewed, they actually thought that there was a pretty decent chance that they'd find some sort of trace of life or something like that, biological process, which is extremely interesting to me, because it's sort of like that answer, not exactly are we alone, but does life try to fight to exist no matter what the conditions are?
And one thing that we know for sure is there has been water, because that was, initially one of the questions when we started sending like Curiosity and Opportunity back in 2004, when we started sending those rovers up. The first question is, well, was there water on Mars? And now that's a for sure thing.
Right, that's undebatable at this point. And something interesting about that is that on Earth, as long as it's not an extreme end of the spectrum, basically wherever there's fresh water, there's life. So that's something that's really positive and really exciting. That's like got me watching the clock to try and see what this rover can find. So some other instruments on here, the cameras, the main camera on the very top, the super cam, you can see it here. right in the middle. It's called the Mast, I'm pretty sure. And that's an upgraded camera. It's an upgraded version of the one that was on Curiosity. And using that and some other lasers that they have installed on it, they can beam them at rocks and the surface of the soil. And based off of what vapor is created from that, they can tell what the elements are inside of it. And the main point of it on this one, on this rover, is to see if there's anything that could be possibly toxic to humans on the surface that we should watch out for future missions there. Underneath the rover on the bottom side is almost like a mobile laboratory, which is going to be taking core samples of the Martian soil and analyzing them as to its best ability on the surface, but they're going to be stored and cataloged in a way that they know like exactly what sample is what, in hopes that they can be returned to Earth as samples sometime in the future. And a big part of that whole mission is my favorite instrument on this rover, which is the MOXIE instrument. And this is going to be trying to convert the Martian atmosphere, which is mainly CO2, into oxygen. And the reason they're trying to do this, and the reason it's such a big deal, is that that can be used as an oxidizer for rocket fuel. And if they didn't have to carry that with them, that would really save a lot on cost and the number of trips and ultimately time that it would take to get those samples back to Earth. Same thing for humans going to Mars. There has to be a way to get them back, and without taking multiple trips before that to bring all the supplies necessary to get them home, this could be used to rapidly cut down on the cost and the price, or the cost and the time, which is really cool.
I mean, that is critical, because Mars being so far away, if we are going to fly there with astronauts and hope to, which I guess we would plan to, get them back home, rocket fuel is, it'd be nice to be able to make it there on Mars instead of having to bring that with us too.
Yeah, definitely. It's a hot commodity for sure. Also, something cool in the sky to see during this month is Jupiter, which is a negative 2.7 magnitude. So you can't miss it. It's one of the brightest things in the sky that you can see that's not the moon or Venus. It's going to be ending the month at negative 2.6, so slight change. It's going to be 47 seconds of arc, fairly large. And it's going to be visible in the evening to the southeast, rising before the sun goes down. So the thing that's limiting your time on observations is when you can actually see it, when it's dark enough.
So Adam, if just to interrupt for a second, when you say 47 seconds of arc, what part of a degree is that? What does 47 seconds of arc actually mean?
So 60 seconds of arc is the same thing as a minute of arc, just like 60 seconds in a minute. And then there's 60 minutes in a degree. So relatively it's pretty small, but in the terms of astronomy, it's actually somewhat large, because a disk can definitely be revealed through a telescope. It will be in conjunction with the moon on the 28th. During this, you can view the Galilean moons, Io, Callisto, Europa, and Ganymede, which are always great to see. And speaking of the moons, on August 14th, after 10:30 p.m., there's a transit of both Ganymede and Io, where you'll be able to actually see the shadows crossing the surface of Jupiter. Definitely can't miss that one. That's all I got.
Okay, thanks, Adam. Good job. And if anyone is interested in checking out with your telescope, again, the transits of Ganymede and Io, you can check that out online, but it's definitely something worth seeing, to see like that shadow of the moon go across the face of the clouds of Jupiter.
Absolutely.
Very impressive.
Yeah.
All right, thanks, Adam. And Seth, you're going to tell us about some constellations and Saturn.
Yeah. So I've got a couple constellations to talk about. The first one I'm going to talk about is Sagittarius, also known as the Archer. It's a fairly large constellation, and there's very distinct asterism in it called the Teapot. It's right here in the middle, and it really does look like a teapot. And one of the interesting things is the Milky Way is kind of in this area, and the spout of the teapot kind of almost looks like it's pouring out the Milky Way, or that's like the steam coming out of the teapot. There's a lot of Messier objects in and around this constellation, as well as the Pistol Nebula, which contains the Pistol Star, which is one of the brightest stars in terms of absolute magnitude, like in the Milky Way galaxy. But it's very dim to us observing it because it's surrounded by dust and particles in space, so it's very dim to us. And this shape, it is called the teapot. But these three stars here are actually the bow of the archer, and the three stars are called, I wasn't 100% sure about the pronunciation, but Caus Borealis, Caus Media, and Caus Australis, which mean northern bow, middle bow, and southern bow. And those are three of the brightest stars in the constellation. The next constellation, which is like right next to Sagittarius, is Scorpius. This picture is kind of, it's like vertical. It's normally kind of flipped on its side here when you're looking at it. Scorpius is the scorpion, and it used to be a lot larger than it is today. The Romans actually changed part of the constellation, and they essentially cut off part of the constellation and turned it into a constellation I'll be talking about after, Libra. The most prominent star is Antares. It's a magnitude 0.9. So it's fairly bright. I think it's the 15th on average brightest star in the sky, something around there. And it's 554 light years away. And it's very distinctly red. It's a red giant. It may be a supergiant, I'm not sure. It's very distinctly red. The shape, you can see here kind of the shape of the scorpion, and this is the tail, the star Shaula. And that part of the constellation starts to pass through the Milky Way.
And you mentioned Antares, and another factoid about Antares is it's, as you said, 554 light years away, but it is huge.
If it was in our solar system, it would be like out to Mars or something, I think. And
yes,
an interesting thing related to the mythology is it's directly opposite in the sky from the constellation Orion. And in the story of Orion the Hunter, the goddess Artemis sends the scorpion to kill or to hunt down Orion. And so he's keeping his distance all the way across the sky. And the last constellation I'm going to talk about is Libra. And I briefly mentioned that Scorpius used to be quite a bit larger, and Libra used to be the claws of Scorpius until the Romans changed it to be the scales, which are like a symbol of justice and balance. The two brightest stars in the constellation, these two right here, Zubin Eshemali and Zubin el-Ganubi, those are derived from Arabic phrases that mean northern claw and southern claw. So that's kind of like a remnant of how they used to be part of the Scorpius constellation. As a whole, the constellation's relatively dim. Zubin Eshemali and Zubin el-Ganubi are the two brightest stars in the constellation, and they're, I think, around a magnitude 2.5 or 2.6, and they're very close to each other. Zubin Eshemali is actually the brighter star, despite having the distinction or the designation of beta, and Zubin el-Ganubi has the designation of alpha. Zubin Eshemali is actually brighter by just a little bit than Zubin el-Ganubi. It's also home to the star Methuselah, which is the old star that we know of in the universe, with an estimated age of about 14.4 billion years old, give or take 800 million years.
give or take.
Which is, give or take, just, which is interesting because our estimation for the age of the universe is 13.8 billion years. So, but it's an estimate. So scientists think it was formed just after, or relatively after, the Big Bang happened.
So this would be one of the original stars.
Yeah, primordial star, if you will. And this is just a shot from Stellarium, the astronomy software. It just shows the three constellations in relation to each other. They're kind of all in a line. And you can see with Scorpius and Libra how you can kind of see how this sort of used to be one constellation here. And you can also see, this is a good segue, you can see Saturn and Jupiter up here entering into Sagittarius, which leads me to be talking about Saturn. Saturn, alongside Jupiter, is one of the most prominent things you can see in the sky right now. It's not quite as bright as Jupiter, and Jupiter was a negative 2.7. Saturn is kind of hovering around 0 magnitude, but it is close behind Jupiter, so it's pretty easy to spot. It's about 9.5 AU or 1.5 billion kilometers from the sun on average. Its radius is 58,232 kilometers, and if you include the rings, it's quite large at 422,730 kilometers, which is about 8 times the radius of the planet. It has an orbital period of 29 years, but the actual length of the day is quite short. It's about 10.5 hours, but that's kind of difficult to get a solid number on due to the fact that it's like a gaseous surface. Another interesting thing about Saturn is it's actually the flattest planet in our solar system, so it's kind of more of a ellipse or an oval compared to other planets in the solar system. It also has the most moons in our solar system with 82, 2 of which are shown below. Titan's on the left and Enceladus is on the right. Titan has a very thick atmosphere, so that picture you might be able to see some kind of straight lines and what looks like squares on it. That's a mosaic image made up of several different images. And then Enceladus on the right is a very icy moon, which distinct about it is it has geysers that can be seen coming off of it. So I talked a little bit about the magnitude. It's a 0.1 at the start of the month and 0.3 at the end. And then angular diameter, just the planet itself, the disk is 18 arc seconds. And then with the rings, it is 41. When you're looking through a telescope, you can very clearly see the rings. Even with kind of a weaker telescope, you can see the shape of the rings in the disk. And it's a really, really beautiful thing to look at through a telescope.
And if I could interject, when back in 1609, when Galileo was training his telescope towards the heavens and looking at Saturn, his optics and magnification, optics, resolution was not good enough to distinguish rings at that first sighting. But when he made his drawings, he said it looked like Saturn had ears. And you mentioned the magnitude, and Adam did also earlier. Can you just explain a little bit of magnitude? What do these numbers mean? What does it matter if they're larger or smaller?
It may seem a little like counterintuitive, but the higher a magnitude is in the positive direction, that's a dimmer object. And generally, objects that are of a magnitude less than 6 are pretty much, you can't really see them with the unaided eye. As things get lower and lower, they eventually will surpass 0, and you'll have negative magnitudes, like Jupiter is a negative 2.7, those are fairly bright objects. There's not a ton of negative magnitude things in the sky. I think the sun, if you were to measure it, the magnitude, it's like negative 26.
Yep.
Or something along those lines. I think it's a logarithmic scale, so it starts to ramp up pretty quickly.
Yeah, each magnitude is
2.5.
About 2.54, something like that. It's the 5th root of 100.
Mm-hmm.
And you mentioned the counterintuitive part, and without going into a long story, Hipparchus, somewhere 300-ish BC, he wanted a way to quantify brightness and got some of his buddies around. And of course, the Greeks are all into Olympics and racing and stuff. So basically the idea was, well, a magnitude 1 would be the first place star, right? And a magnitude 2 would be like the second, not as bright as 1. And the third place would be magnitude 3, et cetera, like that, down to, as you said, magnitude 6, which was kind of at the limit of visibility. And now, in recent years, when we have the ability to do metrics with our technology, we know that things are a lot brighter than a 1. So they kept the 6 as being the boundary of human visibility for most people on a clear night, but they had to extend that logarithmic fashion, as you said, the 5th root of 100 into the negative numbers.
One more slide. Both Saturn and Jupiter are in Sagittarius this month, and they're very close to each other. So they're pretty easy to find. And on the 28th and 29th, they're going to be close to the moon. I think Saturn is the 29th, Jupiter is the 28th, as Adam mentioned before. So they're really not too difficult to locate in the sky, and I think they're two of the coolest things you can look at. Being able to see the rings of Jupiter, or the rings of Saturn, and the Galilean moons on Jupiter. It's really awesome to look at. And one last little thing to look at for people who like to get up a little earlier. Earlier in this month, you can see Venus and Mars at dawn, and Mars will start to be visible in the evening sky later in this month, towards the end of this month. And that is what I've got for you.
Great, Seth. Thank you very much. Yeah, I think Mars is going to start showing up at just after midnight sometime during the month, and then later on we'll keep you all posted. It's going to reach a point of opposition, which will be the most favorable time to view it. But yeah, don't miss Venus if you're up before the sun is in the eastern sky. You can't miss Venus. Somewhere around we're talking about magnitudes. I think a negative 4.7 for Venus.
Brightest object in the sky, the morning sky by far.
By far.
Aside from until the sun rises.
Yeah. Well, great. Well, thanks, Adam. Thank you, Seth.
Mm-hmm.
And so those are some of the neat things that are happening in the sky this month in August. And a few more things we'll tell you about in just a little bit. Well, I hope you enjoyed Adam and Seth sharing about what's going on. And also, we have the Perseid meteor shower. And I want to be sure that you remember the dates on that. So the dates of the meteor shower are August 11, 12, and 13. The best time to view it is going to be after midnight. Every year this time, Earth comes around in its orbit and passes through the debris trail left by Comet Swift-Tuttle. Has about a 130-year orbit around the sun, and this last had gone by around the early 1990s. So as Earth passes through the debris trail left by Swift-Tuttle, that's what causes the meteor shower. Again, August 11th, 11 p.m. after, and you can be looking till August 13th before 5 a.m. But again, days on either side will be fine. And here you can see the North Star in the upper left, come off towards the east, and you come to this W shape, which is Cassiopeia. These two stars will bring you to what's called the double cluster, a great binocular object, and on towards the radiant. So I hope that you enjoy the Perseid meteor shower. I'm Dave McDonald for The Sky This Month.